Hey there, welcome back. Last time I was telling you about a method to create a list of 5-letter words which was terrible, and I don't recommend using it. However, I'm going to keep explaining why it was a terrible idea and give you some more details about why it went so terribly wrong, and then I will finally explain a good method for making a list of 5-letter words. So stay tuned. And by running this list, we would eventually compile a lot of actual words. But two problems come up. Well, several problems come up. One, the main problem is that when I actually ran this, it took me 3 days of letting my computer run in the background for it to complete. And even when it completed, it only generated something like 9,700 words, where the full list of words that you could generate would be over 12,000. So it took 3 days to run on my laptop, and it was incomplete. So those are not ideal results. And then another really sticky point, as I found out, was that you'll often generate your permutations when you have multiple repeated letters. That means you're going to generate the same word multiple times. And so then you're going to create a list where the word apple shows up maybe 5 times in the list, which is also not ideal. To get around that, I created a set. So when you you can convert a list into a set, and that will remove any multiples that you have in the list. So that's something that I could solve with Python. But the real way to solve this is just to totally abandon this approach and to make a better 5-letter word discovery tool. So let us, here, I'm going to delete everything except for the alphabet here. And we really don't need the enchant library or permutations for the thing that we're going to make. But we will need that the other thing we imported. So we would say now from NLTK dot corpus import words. We'll still import string, and instead of alphabet now, I'm going to do something called uppercase. Now what I've discovered is that the words that you get from this NLTK corpus are a comprehensive list of words, but it includes proper names. Proper names have a capitalized letter in the word, and we don't want proper names in our list of words. So to get rid of them, we'll generate a list of all uppercase letters, and then I'm going to test the first letter of each word, and if it's uppercase, I will reject it. So uppercase. And so instead of it being ASCII underscore lowercase, it will be uppercase. All right, so this generates a list now of uppercase letters. Now, so now instead of generating through this permutation of nonsense words, we'll be parsing through a list of all different lengths of letter words, right? And so now our test is much easier. For one, we have a much smaller set that we have to deal with instead of just the permutations of all. It's like going from all irrational numbers, irrational and rational numbers, to just looking at rational numbers or something, right? We're looking at numbers that are 10 letters long, numbers that are 2 letters long, etc. And we can just test, does the word have 5 letters? That's a much easier test and a much faster test for Python to parse through. So we will say we need to create a word list. So word underscore list is going to be equal to words, our import, dot words. Open close parenthesis. That's it. We just now have generated, once the program runs, a list of all English words. The NLTK.corpus, I guess, already uses the English dictionary words. So we've generated our word list, and now we want to simply run through it. I have grown to like using enumerate to go through lists because it gives you the index as well as the word, and that may come in handy. So we're going to start with that. For I, comma, word in enumerate word underscore list, colon. And I tab out. And now we just use our test. If length of word, equals, double equals 5. So we could stop there, right? If length of word is 5, then we want to keep it. The other test we want to have is to say, okay, if there's no uppercase letters in the word, and I really want to limit it to just the first letter as uppercase, right? That'll get rid of all proper names. So we can just say and word 0, meaning the first letter, is not equal. We'll say not equal is exclamation point equal. Or you can also say not in uppercase. That's really what you want to say. So if the first letter is not in our list of all uppercase letters, that will comprehensively catch all words. Because we really don't want to say it's not equal to something. We say it's not in the list of uppercase letters. Okay. So if both of those are true, then we want to add the word to our list. So in this case, I'll show you now how I make the set of numbers, and then how I make sure that I only add unique words in case somehow in this corpus of words there are multiples of the same word. So we'll say op equals set open close parentheses, Okay. And some of this language here with set was new to me when I created this PyWordle game. So if it's new to you, it was new to me too. All right. So this is how I made sure only to take an action if we increased the length of the set. I would say len op1 equals len op. All right. Then I say op.add word, and then I say len op2 equals len op. So what have I done here? Before I start, I take the length of our set, meaning how many elements are in the set. Then I add the word to it. Now, if I add a word that's already in the set, it will not increase the it won't increase the length of the set, because it will say it's a set, you've already added this, we're not increasing the length. So then I take another length, and then I will compare the length before I added the word and the length after I added the word. And if those lengths are different, if the second one is greater than the first one, then I've increased the number of words in my set, and at that point I could print the word, or I could add it to a list of words. So in this case, we're going to add it to our currently empty 5-letter words list.txt. Okay? So this just ensures that we're only going to add unique words. If len op2, well, here's what I said. I said if len op1 is not equal to len op2, that's the only test. As long as they're not equal, then we'll print the word. Just for fun. And then we'll create a file. And we're going to make a file that we constantly open and close. And the reason that we're going to do that is that if something happens and we have to kill the program, we want to save all the words. We want the words that we've made to be saved. So when you open a file for writing, you can open it for reading only, for writing, or for appending. And if you open it for appending, then it will look and see if a file is there. If not, it will create it. And if the file is there, it will open and just start adding to the end of that file. That's what we want to do. So I'm going to make our 5-letter word file. And I'll say open. And the name of it is 5-letter words list.txt. Okay, and we want a comma and give it the signal A. A means append. So that's what we're opening it for. once that file is open, we need to write the word. So flw underscore file dot write word, and we're going to, after the word, we're just going to introduce a space. A word plus a space. And yeah, maybe we can just add a comma in there too. So now we'll have a list of comma-separated words. To format it, we might like the word list to end at a certain point so that we don't have too many words in our word list. So we can say, we can use the length of our list as a test. We can say if len op2 percent, we'll say 10 equals 0. So what that means is that every time we get to a factor of 10, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the next one is 10, right? Once we get there, we're going to write this other thing. So we just want to insert a new line character, really. flw file dot write, and /n is a new line character. Okay, so this says that if the number we've chosen for lenop2, not chosen but discovered, if the number is a multiple of 10, is what that is. This percent in this case means modulo 10, and by setting it equal to 0, it means that it is a fixed multiple of 10, or it may be in fact a multiple of 9. I don't know exactly right, but it's going to do this every 10th letter. Is the behavior that we want. So every 10th letter we write a new line character. So we should have 5-letter words, and then at the 10th one, it'll do a carriage return and start new 5-letter words, okay? All right, so then what? Then, maybe unintuitively, 5-letter word dot file, or underscore file, close. So we're going to quick write that word and maybe write that new line character and then close. So the reason we're doing that is that if for some reason we have to kill the process somewhere in the middle, we will have saved all the words that we've written so that we don't necessarily have to go through them again. And we could write crazy logic that says if the word's already in the file, then don't write the word. That's perhaps not necessary at this point. I hope that we can execute this and see our 5-letter word list populating as we go. But I think that that's it. So I am going to now go back to our screen, and I'm not going to make us watch this whole thing, but I will show it at the end and show it getting started. So it's going to print the words to the screen as it goes, and then I'll also show it populating that text file as we go. All right. So those are all real words, and it's going through them rather quickly, and it finished. Wow, that was much faster than I thought. Now, you might remember our 5-letter words file was empty, and I'm being told, you can't see it here, but it says it's been modified. Do I want to reload it? So I say yes, and kablam. Now we have a ready-made list of 5-letter words. And if you look for a word, Control F. So we want to find the word error. Is it in there? It is. There it is. So again, a word that my stupid brute force program would not have found is in fact in this word list. Now, here's the problem, right? Iruka is also in here. I've never heard of that word. You've never heard of that word. No one has ever heard of that word. You know, Erose, Erizo, Erica sounds like a name. All these words are very weird and esoteric, and we don't have a lot of commerce with them. So I would say that it could be a good now practice to somehow manually go through this reduced list of words and pick out words that you think are good words for a Wordle game. When we do our Wordle game, we can use these words. We can use the official list of Wordle words. We may also decide that we can just we can get away with something else. Like we could just use a truncated list of 10 words so that we always know it's going to be one of those 10 words, just for the purposes of creating our game and testing it. And then once the game is good, we can go to the 5-letter words list here, and we could spend some time parsing it down or paring it down, getting rid of, or somehow, getting rid of words that, like penta, right? Again, not a word we use a lot. Peony, again, it's an interesting word. It's a flower, I believe, but it's not super common. So yeah, you want to kind of use a human brain to figure out what words would make a good Wordle game, because if people are trying to figure out the word, I don't know, proem, they're going to be mad because they've never heard of that word. So there's a lot of words in here that we've never heard of, so we have to use some of our brain to figure out a good way to parse them down. Okay, well, I'm going to cut off this tutorial here. We have made a list of 5-letter words fairly easily. It didn't take 3 days, and it didn't take a computer churning all that time. And so in the next tutorial, we will move on to some of the actual Wordle game, where we're gonna probably have to download a few more modules that we didn't download today, and we'll start working on how to make the colors appear. If we have a word selected that we're trying to guess, how can we start doing the logic that says, okay, this letter's in the word but it's not in the right place, or this letter is in the word and it is in the right place, or this letter's not in the word. So all that logic will be unraveled, and we'll see it, and then we'll take that, and the results of which will turn into printing a color to the screen. Thank you for watching today, and we'll see you in the next one.